Hello, we are going to be working with our Lesson 3 notes, the notes that we took yesterday, and more specifically, we will be checking the practice problems that you should have completed before class today. So, make sure you have out your Lesson 3 notes, turn to the practice problems, and we will start here. Now, on this first one, we are matching our dilations to a scale factor. For reference, the blue rectangle is going to be our base for each of these dilations, and the green rectangle will be our image. So blue pre-image, green image. So start and end. Now, whenever we dilate things, we are changing the side lengths, meaning we are multiplying the side lengths of our base by the scale factor to create a new rectangle. Now, whenever we multiply something by a fourth, that will be smaller than whenever we multiply something by a half, because that is a smaller scale factor. So if you're having trouble knowing which one is smaller than the other, then you can go ahead and plug them into your calculator and you will get some decimals, which might be easier to compare. So if we are looking at our smallest scale factor, that would be this first scale factor of a fourth, or 25 hundredths. And that is smaller than both half and then 75 hundredths. So the smallest scale factor would cut the rectangle into the smallest out of our three dilations. So we're going to match the smallest rectangle to the smallest scale factor. We're going to do the same thing with the next smallest, which would be our scale factor of a half, or 0.5, 5/10. So if we look for our next smallest dilation, that would be dilation C, which is kind of our medium. It's our medium image. And then that leaves dilation A, or the largest image, to match with our largest scale factor. Okay, with that, we're going to go on to the next problem. Here we are working with a pyramid in Egypt. Pyramids are really cool because we can actually see the different levels and maybe see the plans if it's been mapped out. So here we have a nice diagram for us to use. The first question is saying, what scale factor was used to create the cross-section? That cross-section is the one in the middle. That is about 96 meters higher than the base. So as we are looking at what scale factor was used, first we need to find some corresponding parts to help us find a scale factor. So here are some corresponding parts where we know both of those parts. So we know the cross-section is 96 meters above the base, and that the top of the pyramid is 144 meters above the base. So we can use those to help us find our scale factor. So now we know that we need a cross-section smaller than 1, a scale factor smaller than 1, since our cross-section has shrunk from the base. So I'm going to arrange this with the smaller number as my numerator, or 96 over 144. In a fraction, in a simplified fraction, that would be 2/3, or approximately 667 thousandths. Now we can use that to help us answer the next question, which are, what are the dimensions of the cross section? By dimensions, we mean the sides of that square. And notice here, I also have corresponding parts matched up as well. So we know that the side of the square on our base is 231 meters. And then we're going to use that and multiply that by our scale factor to get the other measurement, or the dimensions of our cross section. And that will get us 154 meters. This question is asking us what scale factors of dilation are represented in the figure's cross sections. So that means anywhere from that base to the top where it's cut off. To help us contextualize this, I'm going to extend the rest of this to find that center of dilation, just to help us visualize it a little bit more and help us really see that pyramid. So at the very bottom, that would be our scale factor of 1, because multiplying by 1 would not change that base. The very top at that point would be a scale factor of 0. So that would be right down to that point, or to nothing really. So in the middle is where we're looking now, and that middle is probably about half if we're looking at the options we have here, which is a half, a fourth, and 3/4. I would say this is closer to a half than those other two. So if we're looking at a cross section of a half, and we're trying to find the range of all of our cross sections, that top at 0, we don't even have. We had to fill that in to get and to visualize our scale factor of 0. So anything with a 0, we can go ahead and cross out. In the next part, if we look at what we do have from about 1 to a half, that would be question D, or answer D. And let's go on to the next one. With this one now, we're looking more at cross sections, and specifically we're looking at cross sections of a cone. So to help us visualize this, I am going to put a cone right here on our screen. The first one, A, is asking for the horizontal cross section. So if I take this cone and slice it horizontally, I will end up with a circle. Question B is asking for a vertical slice through the cone's apex, or the topmost point. If I do that, if I slice it from top down, open it up and look at it, I will end up with a triangle. And last but not least, if I cut this at a diagonal, I will end up with an ellipses, or an oval shape. So figure 3. Now on to the last problem. Now we're looking back at what we did in lesson 1, where we were talking about solids of rotation. In this case, that dashed line is our axis of rotation, and here is the figure we are rotating around. So I'm going to go ahead and draw that axis of rotation, and we need to imagine this going all the way around that axis of rotation and spinning kind of like you would with a compass. So you would end up with something like this. It would look kind of like part of an hourglass. It's not quite coming together in the middle, but it does look like an hourglass shape. That is all for this video. Good luck on your formative. You all got this.